Hi everyone and welcome to the Aircraft Certification channel. I'm Clarice Fedel and together with Rafaela we create this space to share knowledge and connect people that, like us, are passionate about aviation. So if you like aircraft development and certification, subscribe to our channel and hit the bell to be notified every time that we upload a new video. In today's video, Rafaela will talk with Anna Sordi about aircraft fire protection. Anna is a Senior Propulsion Systems Development Engineer, and if you want to contact her directly, her contact information will be in the description area. Anna starts describing the elements that are necessary to start and sustain a fire. She also explains that the aircraft is divided in zones according to the fire risk. She explains the prevention means that can be implemented in the design to prevent the fires to occur, and the protection means to control the fire in case it happens. It's not the first time that the fire subject is in our channel. Philippe von Tinsenhausen talks about the fire hazards in the oxygen systems. If you didn't check this video yet, you can do that now with the link that appears in our screen. If you like this video, give us a thumbs up. Also, we would love to receive your feedback and suggestions in the comments area. So welcome aboard and enjoy your journey.
Hi, Anna. Thanks for being here with us today.
Thank you for the opportunity.
Okay, my pleasure. Before we start, could you introduce yourself?
Yes, my name is Anna Sordi. I work on the propulsion system development for over 20 years now. I work specifically in Powerplant fire protection and engine nacelle installation through the whole design phases from the initial design up to the field support. Also, I have worked as delegated from the engineer delegated from the Brazilian Certification Authority. And I'm participating also on the discussions about fire protection tests on the SAE committee.
Okay, and today we are going to be talking about fire, right?
Yes, that's right. You talk about prevention and protection.
Okay.
But before we go deeply in this discussion, the first thing we need to understand is how fire works. And basically, in order to have a fire, we need three components. And that's called the fire triangle. The first component is the fuel. And when you say fuel, it's not necessarily liquid fuel, kerosene and oil. Can also be clothes, papers, anything that can sustain a combustion. The second element we need is the oxygen that usually is normally present on the air, but also we can have higher concentrations that make this worse because reduce the temperature we need for the fuel to ignite. And then the third component is an ignition source. Ignition source can be temperature, electric arc, or spark. The temperature, the necessary temperature will depend on the fuel type and oxygen concentration, as I just said. And the electrical arc and the spark, even though they are instantaneous usually, and they only act on the beginning of the fire, after the fire has initiated, the actual fire temperature starts to work as a continuous ignition source. So we need to take care because the ignition, just a short ignition can result in a continuous ignition due to the fire temperature itself.
Okay, so it means that to sustain the fire, you need these three components. And then if you take one of these components out of the triangle, you then will deal with the fire. Is that what you mean?
Yes, that's right. And that's the way we use to prevent and eliminate and extinguish the fires, eliminate one of the components. That's correct.
Okay, so you mentioned prevention and protection. Can you explain the difference?
Yes, prevention are all the features we do to avoid or minimize the possibility of have a fire, the likelihood of a fire. And protection are the features we design, or the features we have to deal with the fire after it has started. So prevention is try to not have a fire, and protection is deal with the fire after it has started.
Which means that the fire needs to be controlled somehow.
Yes, that's for sure.
And what we'll talk first, prevention?
Yeah, we will start with prevention, but the first thing we need to do in prevention is to understand and analyze our risks. And this we do by dividing the aircraft into zones of risk of fire.
And could you explain what kinds of zones exist, so to classify them?
We basically have three zones. The first one is the zone that we do not have a concern with fire because we will not have the three elements together, neither in a failure condition. So one example, usual example, is the engine inlet, that normally we only have the anti-ice system. We do not have flammable fluid or other kinds of fuel. So even in failure, we will not have all three components together. So that's the fire, the zones that we do not have concern in terms of fire, and we have no protection. But I gave an example here, and I would like to point out that through the conversation, I'll probably give you a lot of examples. The examples I give is a common saying, a common design, but fire is really tied to a specific design. So when I say pylon is a new engine inlet is an unusual area. We do not have fire concern. It does not mean that every aircraft is like this. It's really dependable on the design, but most or a big portion of the airplanes, the engine inlet is a zone that is no risk of fire. The second zone is the flammable fluid zone. The requirement 25863 asks to define the zones where the flammable fluid can escape, and we need to identify those zones and minimize the occurrence of ignition and the hazards if ignition occurs. So for those zones where I can have an ignition as a result of a failure, I need to have prevention features, because with dual failure, so the failure of a flammable fluid leakage and the failure that will cause an ignition source, I can have all three elements of the fire because the oxygen is normally present in the air. So for those zones, I do need prevention. Most of the time, prevention is sufficient. There are cases, as I said before, depend really on each design, that a protection is also needed. One good example of a flammable fluid zone is the pylon, because usually I have the flammable fluid line, I have ECS duct, I have harness, all in a small compartment. So this is normally a flammable fluid zone. The third zone we have is the zone that we have, besides the oxygen, another one of the three elements normally present on the zone. So we only need a single failure to have all three components. And when I say that, don't be scared. It's not that it's a zone that it's high probability of heavy fire. No, that's not correct. In this zone, we also must apply all the prevention features. Okay. So it's safe. If you look the historical data, events of fire in airplanes are a small quantity. We take all the care, but besides all the care to prevent, we also need to take care, to take protection features, to make available protection features in case we do have a fire, because this can come from a single failure, regardless of the probability of the failure.
Okay, so which means that
Okay.
we need to do everything that we can to prevent the fire from happening. But if it does happen, in case of a fire, then we have to act on the protection. So protecting the aircraft and its systems to not be harmed by that fire. Is that right?
Yes, that's correct. That's exactly right.
Okay, so now once you have classified the zone, how do you know what's required?
There are two things you need to take a look. One is what this zone needs in terms of protection, and we'll describe this a little later. And the other point that you need to pay attention is there are some requirements that asks for a specific protection, regardless of the zone classification. Usually they are in line with the zone classification for the common design, I would say, or the usual design, but some aircraft may have a specific design. But I will give here some examples to make that a little more clear. One example is the requirement 851 that asks for hand fire extinguisher on the cabin. So on the cabin, we normally have clothes, we have paper, and we have oxygen. So we just need the ignition. So it would be classified as a zone that needs to have protection anyway, but the requirement specifically asks for fire extinguisher. Other example is the requirement 251181. Requirement 251181 define some designated fire zones. What's a designated fire zone? Is a zone that, regardless of the classification, based on the potential risk, shall be treated as a fire zone. And one of those is the combustor region. But the combustor region is, the combustor case is very hot, and we have few lines coming in. So most of the designs, it would already be classified as a fire zone anyway, but the requirement also asks. So you need to do the classification based on the environmental you have, as well as on those specific requirements.
So, and now let's talk about a little bit of the prevention. What can we do to prevent the fire to occur?
Yeah, the usual prevention features are physical segregation. So instead of passing a flammable fluid line close by a, for example, hot duct, ECS hot duct line, when the fluid could spillage on the duct if they are close, you put them far away. And then even if I have a spillage, will not reach the hot source. The second feature can be shroud the flammable fluid lines. Insulate the air ducts also is a prevention feature. Using spark-proof connectors that are qualified as explosion-proof per DO 16 is also a prevention feature. And drain and ventilation to eliminate the vapors from the zone. Those are the most common. Again, each design can have an additional specific feature, but those are the most common features.
So it's like, again, taking one of the three components from the triangle out to eliminate the possibility to have a fire, right? So either fuel or ignition source or oxygen, right?
Yes, that's right. It's always trying to not having all the three together.
Okay, but you mentioned about ventilation. So wouldn't increase the ventilation also increase the oxygen? So how does it prevent the fire itself?
Yes, that's right. Additional ventilation, a little bit of additional ventilation would increase ventilation, it would increase oxygen concentration, sorry. But also what happens mainly with flammable fluids is that they have a specific range of fuel air mixture in order to be flammable. So a mixture that I have just a little bit of flammable fluid vapor and a lot of air, this is a lean mix, what we call lean mixture, and this does not ignite. Then if I have good quantity of fuel vapor and good quantity of air, then I have a flammable zone. And then if I have a lot of vapor, fuel vapor, but just a little bit of air, we call this as rich zone as well. And this also does not ignite. So the idea of the ventilation needs to be a ventilation that is such that you guarantee that the zone will stay on the lean side. So a small ventilation would increase, well, the ventilation increases a little bit the oxygen concentration. But if this removes the flammable fluid vapors, this helps to not have a fire.
Okay, so it's not very intuitive, but I think I understand what you mean. So a little ventilation would actually feed oxygen to the fire, but kind of a strong ventilation can really clean the environment, right? And vapors.
Yes, that's right. And there is an ARC document that's very good that helps in defining how much of ventilation would be enough or necessary to make this help to not to prevent this fire, to make be on the lean side of the mixture.
Okay, understood. And is there anything else about prevention? And
Yes, one important thing on prevention is that sometimes it's not possible to use all the features together in the same zone, but you must use as much as practical. That's the most important thing because not having a fire is very good for everybody. So use all the features you have available to prevent the fire. The second point that's important to mention is that this should be looked and analyzed early on the program, very on the beginning of the program, because the development. Because what happens that sometimes the design features may change a classification of a zone. For example, as I mentioned before, if I put a flammable fluid line very close to a hot air duct, that's a fire zone because the leakage of the flammable fluid can touch the hot duct and ignite. But if I put them far away, I shroud the flammable fluid line, I insulation the hot air duct, then I have a flammable fluid zone. So it's very important to look this on the beginning of the program. Also, you do not want to find out later on the design that you need to add a feature. That's always painful. So this should be analyzed on the beginning of the development.
okay, and nobody likes changes later on the process. And also, I mean, every kind of protection means also means more weight because you're adding things to the system. So you also need to balance that, right?
Yes, that's right. Always prevent a fire is a good thing. But you can, if you do on the beginning of the program, you can analyze with care and have the less weight
Yeah.
features, choose the materials and things like that to always
Yeah,
have
optimize
uh,
your
a good
design.
feature without penalizing the design, the whole
Okay.
design.
And so once you have classified as a fire zone, so you talked about the prevention means, but besides the preventions, what can you do to control the fire if it happens? So what are the protection means?
Well, the main protections are fire detection, fire containment, shoot-off means, and fire extinguish. Those are the main 4 protections.
But do you need to use the 4 of them all together?
No, you need to really analyze your zone, and that's the fun part of the job, I would say. You need to look zone by zone and understand your zone. So I will give here some examples. There are some landing gear systems that don't need any protection, but there are some where I can have a leakage of the hydraulic fluid touching the hot brakes. Then for those designs, usually we have fire detection. But only fire detection because when I extend the landing gear, this will give me enough ventilation so I can protect the aircraft from the fire. On the other hand, for example, usually for engine, APU, cargo compartment for a commercial aircraft, they require fire detection, fire extinguish, and fire containment. Other example is on the cabin. I don't need fire detection because I have people there. The people who see the fire, they are the fire detectors. Shoot-off beam also is only applicable when I have flammable fluid fire. So really depends on your zone. You need to analyze zone by zone, understand your fire, and define what are the most applicable protection features.
Okay. Can evaluate your design and find the best solutions for that particular design. And
Yes.
yeah, it seems like there's a lot to be explored on the protection means. So I think we don't have the time to go through all the details here, but maybe we could do a future video about it.
Yeah, I will be glad to come back and talk a little bit more details on the
Okay,
protection. That's for
so
sure.
you're already invited.
Thank you.
So could you kind of summarize the steps that we talked today?
Yes, so the first thing you do is to preliminary define your zones. The second thing is apply all prevention features for the applicable zones where you have fuel and flammable fluids. Then you reclassify your zones considering the prevention features you applied. And then finally, you define what are the necessary protection for the applicable zones.
Okay, and in terms of aircraft certification, what are kind of the main requirements that are applicable to fire and fire prevention and fire protection?
For part 23 and 25, we have two set of requirements named fire protection. One at the end of subpart D that's general for the aircraft. Another one at the end of subpart E that's more dedicated for power plant fire protection. Those are the main two sets, but we also have some other requirements on each dedicated system, and those you need to take a good look because they not always are called fire protection.
Okay.
But we have this for electronic system, you have that for fuel system, for landing gear, as I gave the example before. So you need to go on each system as well. You have some fire protection requirements.
Okay, so although you do have like a subpart, which the subpart D and E for fire, you still need to dig into the disciplines to kind of select the ones that are applicable to fire, right?
Yes, that's correct.
Okay. And what would be your considerations regarding the prevention and protection when we talk about the use of new materials and new technologies?
Well, I would say that with new technologies, always the care you need to take is to guarantee both that we maintain the same level of safety or improve it, and also how you demonstrate this level of safety. For Spire is one good example because many years ago, the nacelle and engine cases were pretty much metal. And then we start to use composite materials. So even though for this the requirement for fire containment has not changed, the way to demonstrate that the components are able to withstand fire has changed a lot. So by that time they issued an AC 20-135, and now 30 years later we are still discussing and harmonizing these those methodology. As I mentioned on the beginning of the video on this SAE committee, to put all the knowledge together. So new technologies always bring challenges, and they sometimes take some time to mature, but we need to keep in touch and keep maturing the requirements and methodology, and new technologies will always come. And for the eVTOLs, especially, that's new technology coming soon. Um, what happens, the recommendation I would give for the OEMs is to take a special look on the fire protection of the batteries. The batteries are having new technology to increase the charge capability and the timing, a faster time to recharge. So please take a look and a special care to guarantee that the fire risk is still low, and you have ways to control it.
Yeah, I think there are a lot of challenges involving these new and big batteries for the eVTOLs. So let's see how manufacturers and suppliers they all come through this, and authorities, of course, solve these challenges. Yeah,
Yes.
so Anna, very interesting material, very interesting conversation. So I'd like you to thank you again for being here with us. Already inviting you for another video, kind of going a little deeper on the prevention and protection means. So really a pleasure talking to you.
I thank you, and I really appreciate this talk. And okay, I will be back soon with the fire protection discussion.
If you want to contact Anna directly, her link will be in the description area. I'd like to thank you for watching. If you haven't subscribed to our channel yet, please do it now. See you in the next video and enjoy your journey.